Alright everybody, we're going to take a look at our simplifying radicals that we've been working on here the past week, a little over a week. So several things we're going to get through today on this video, but start with, in my opinion, the most important of everything, just being able to simplify a radical in general. Okay, so looking at square root of 48. We want to simplify that. In other words, take out any perfect squares that are in 48. So we're going to look at two different ways of doing this. The first one, you could list out all of the factors of 48, so all of the pairs of numbers that multiply to 48, as I'm doing here on the board. Or another way of listing these out without actually writing them is in your calculator you're taking 48 divided by 2, 48 divided by 3, 48 divided by 4 to figure out what these pairs are. Okay? Now, what I've suggested in class is instead of using 1, 2, 3, 4, 5, etc. as your numbers, focusing on the perfect squares, which we know are 4, 9, 16, 25, 36, etc. So you could take 48 divided by 4, 48 divided by 9, by 16, all the way down the list, looking for the biggest perfect square that's a factor of 48. Okay, so I've got these listed out here in blue. I notice, hey, 4 is a perfect square, 16 is a perfect square. Which one's the biggest? Okay, well, clearly 16 is the largest perfect square. So 16 and 3 is my pair. Square root of 16 times the square root of 3, because 16 times 3 is 48. And the square root of 16 is 4. Okay, so square root of 48, 48 is almost 49, so I know the square root of 48 is going to be really close to 7. It's about 7 or just short of it. Square root of 3 is approximately 1.7, so 4 times 1.7. Little math on the calculator, 1.7 times 4. 6.8, which we said it was going to be slightly less than 7. I can see the square root of 48 and 4 square roots of 3, just by doing a little estimating there, are in fact the same thing. So that's one method, looking for factors that are perfect squares. The other method, using the factor tree. So finding the prime factorization. I'm just going to break down 180 into prime numbers. 5 and 9, 9, 3 and 3. And I'm still looking for perfect squares, but I'm going to look for pairs of numbers here. So I see that a 2 and a 2 is a 4. 3 and a 3 gives me 9. I'm looking for pairs because a perfect square is a pair of numbers. So 4 is the same as 2 times 2. 9 is the same as 3 times 3. Okay? So I found 4 and 9, so what I need to do is multiply 4 times 9, and then notice I still have a 5 here, so times 5. So my breaking down 180, I'm going to break it down into the square root of 4 times 9 is 36 times the square root of 5. Okay, once I do that, square root of 36 is 6 square roots of 5. Now, one way I know I'm finished in both of these is that my 5 here is a prime number, my 3 is a prime number, and I can't move on from there. I can't break those down any further. Okay, so that's a quick review over just simplifying simplifying radicals, in this case square roots, just in general. Now, then we talked about simplifying when we were adding them together. We compared this in class to a problem like this. So 1x plus 2y plus 9x, and we would say, well, how do we do that? Well, we combine like terms. We're looking for the same variable and the same exponent. We'd combine the x's, there's nothing to combine the y's with, and we'd be good to go. Same thing here, just we're combining their radicals, the square roots. I've got 1 square root of 7, don't forget there's a 1 out there. I've got 9 square roots of 7, so total, I've got 10 square roots of 7. Plus 2 square roots of 5. 7 and 5, those are different. Nothing else I can do, and I'm good to go. Okay? So this is my final answer. Okay, next, what if I have a problem such as these where I don't have quote-unquote a like term, so 54 and 96 are different? Well, I'm going to start off by seeing if I can simplify them. If I can't simplify these, then this is all I can do. There's nothing for me to do. As I look for perfect squares that are in 54, I notice that, well, 9 times 6 is 54. I do the same thing for 96. And I notice that, well, 16 times 6 is 96. I simplify from there. 3 square roots of 6 plus 4 square roots of 6. And now I've got the like terms that I'm talking about. So another way to think about it instead of like terms is I've got 3 square roots of 6 here. I've got 4 square roots of 6 there. Well, total then I would have 7 square roots of 6. Okay? On this one over here, I'm trying to simplify these two. One thing I notice is that 3 is a prime number. Prime numbers can't be broken down. There's nothing I can do there. So I'm going to automatically right away just say, well, does 3 go into 12? Yeah, 3 goes into 12. 4 times 3. Okay? If 3 doesn't go into 12 and I have something else here, there's no way for me to get my like terms or the same number in the radical I'm looking for. So 2 square roots of 3 minus 7 square roots of 3. 2 minus 7 is negative 5 square roots of 3. Okay? One other comment before I move on here. To check my answer, if I wanted to do that, my calculator, you could do the square root of 12. Whoops. Square root of 12 is about 3.4. And then let's do the square root of 3 times 7. So we're going to do what? 3.4 minus 12.1 roughly, just to get an estimate. So about negative 8.7. So if my answer is right, negative 5 times square root of 3 should be somewhere really close to negative 8.7. It won't be exact because I did a lot of rounding there. It's not exactly negative 8.7, but close. So square root of 3 times 5, and we want that to be negative 8.66, which is right at negative 8.7 like we were looking for. So it's correct. So that's just how I would check my answer. Maybe like on the test, for example, you just want to double check, make sure your answer makes sense. That's what I would need to do. Okay? Moving on. Multiplying. Multiplying, I like using this example right here, square root of 4 times square root of 9, because I know the square root of 4 is 2, the square root of 9 is 3, and 2 times 3 is 6. Well, I also remember that when I'm multiplying here, I'm supposed to take 4 times 9. So the square root of 36, well, what is the square root of 36? The square root of 36 is 6. Okay? So my rule here is these numbers, when I'm multiplying, I'm going to multiply them together. Okay? So let's do that on this one over here on the right. 2 and 7 is what I'm supposed to multiply together. So that's 14. I've got a 3 out front and a 4 here. I need to multiply those. Okay, so 12 square roots of 14. So I multiply the numbers that are underneath the radical, the 2 and the 7. I multiply the numbers that are out front of the radical, and then write them here. Okay? Now, super important point here. Some people are looking at this and they're going to say, well, 14 doesn't have any perfect squares that go into it. You are correct. There's nothing I can do there. If I use the factor tree, I get to 2 and 7. Both are prime. There's no pairs. There's nothing I can do. Okay? Then you might think, well, wait, 12 has a perfect square in it. Sure, you're correct. 4 times 3 is 12. But this doesn't say the square root of 12. It just says 12. No other time would you ever try to simplify 12. 12 is just 12. Okay? The square root of 14, or I should say the square root of 12, is very different than 12. Down in the bottom, same thing I just did. 8 square roots of 18. 2 times 4 is 8. 3 times 6 is 18. So now I've got 8 square roots of, well, let's check and see if 18 can be simplified. And I notice that 9 times 2 works. So 8 times 3 times the square root of 2. 8, 16, 24 square roots of 2 is my final answer. Okay? Same thing, you could get decimal approximations for 2 square roots of 3, 4 square roots of 6, multiply them, double check to see in your calculator to see if that's pretty close to 24 square roots of 2. Okay? Next thing, dividing. So when I'm dividing, let me do that. I should have started off with a basic example like I did in the last one. Let's do this. Square root of 36 divided by the square root of 4, which is 6 divided by 2, which is 3. Right? Square root of 6, square root of 4, 3. Well, my rule is, as you remember from about a week ago, 36 divided by 4 is the square root of 36 over 4. So I need to do the square root of 9. Well, what is the square root of 9? The square root of 9 is 3. Okay? So my rule, I need to take these two numbers and divide them. So over here, I'm going to have the square root of 12 divided by 2, which is 6. On the bottom left, same exact thing. 9 divided by 3 is 3. 24 divided by 6 are under the square root, so I'll do that. And that is 4. Well, shoot, double check before I finish. Can I simplify the square root of 4? Yes. 4 is actually a perfect square. So this is 3 times 2, which equals 6. Okay? So again, using that hilarious little analogy that you guys all love in class of maybe on the birthday cake, happy 6th birthday, or going to a fast food restaurant, ordering a number 6 and just asking the cashier for a 9 square roots of 12 divided by 3 square roots of 6. This thing right here is the same thing as saying 6. Okay? And you look at that and you say, yeah, but we wouldn't actually say 9 square roots of 24 over blah, blah, blah. We wouldn't say that. Correct. Which is exactly why we wouldn't leave it like this right here. It doesn't, there's no point. Why make it harder than it needs to be? We would simplify that in real life. So we're going to simplify it right here. Okay? Last thing here, we learned this just this week. Can't leave a radical in the denominator. We don't want to do that. So we're going to multiply by the square root of 7 over the square root of 7. Remember that anything divided by itself is 1. So this is no different than saying that we're going to take 1 over the square root of 7 times 1. No different. Same thing. But this does help us as I simplify that. My top, 1 times square root of 7. The bottom, some people are like to write it like this, square root of 49, which we know is just 7. Okay, over here, square root of 2 over square root of 2. So I've got 3 square roots of 2 on top and 2 on the bottom. Okay. All right, last thing here, because I got just a little bit more time, and we want to do some review real quick over the nth root, which we actually focused on cubes, fourths, and fifths. So if I do the 4th root of 16, for example, I'm looking for a number times itself 4 times. That's going to equal 16. Well, guess and check gets us there pretty quickly. Is 1 times 1 times 1. Okay, that doesn't work. Try 2 times 2 times 2. Wait a minute. Yeah. That gives me a 4. That gives me a 4. 4 times 4 is 16. Okay? So you're looking for a number times itself, and the best way to do that for what we're going to be doing is just using some number sense and going ahead and guessing and checking and see what you can come up with. Okay? Alrighty, that will conclude our review. Let me know if you have any questions.